So I welcome you again, and we have some new guests to the second part. Roger Tourangeau will tell us something about non-response bias.
Thank you all for coming. Brad and I have now been here almost a full week, and we've really had a good time. People here have listened very carefully to what we said and wrote it down, and this is an experience we've never had at Westat, where people paid attention to our ideas. So it's been a delightful and refreshing change. I know that a couple of you actually attended an earlier talk that's astonishingly similar to the one I'm going to give today, so you can consider yourself members of the pretest sample for this time. And this talk, I think anybody who's worked with surveys lately knows that we're in this bad period, sort of declining response rates and rising costs. And the good news is that despite the fall in response rates, it's not clear that survey accuracy has been affected much. And for people of my vintage and Brad's vintage, it's an article of faith that a survey with a higher response rate is better than a survey with a lower response rate. But empirically, this doesn't seem to be true. And so the first part of the talk is just looking at that paradox. Why is it that response rates don't seem to matter? And then the second part of the talk looks at alternative indicators. So there's been a small set of papers. Barry Shelton of Statistics Netherlands has advocated using the R indicator. The Stats Sweden people, Karl Erik Sarndal and Peter Lundqvist, have advocated using what they call balance indicators. And I'm going to talk about why they don't work any better than the response rate. That's my second paradox. And then the third paradox is, very intelligent people, the best survey researchers in the world arguably have looked at this issue. Bob Groves, they put out the idea that somehow you can fix the problem or at least mitigate the problem through responsive design. And the last part of my talk talks about why that hasn't worked very well either. So this is a totally pessimistic talk, and if anybody's prone to depression, you can leave now.
Yes. We have a little problem with the audio.
Fittingly enough for such a depressing talk.
Oh my God.
Houston, we have a problem.
Should be better now. Very good. And while I'm here.
Oh, get rid of that. Okay. So you may have seen equations like this. This equation asserts that there's two components to the non-response bias. Both of them are related to the response rate. The one component is there are people who have essentially zero probability of getting into the sample. For instance, in a web survey, there are people who either don't have internet access or would simply never do a web survey. And let me see, I'll use the pointer. So this component of the bias is due to the proportion of people who have zero chance of completing the survey, zero propensity cases. And then it reflects also the difference between the cases that do have some chance of completing the survey and those who don't have any chance. So that's this component of the bias. And the second component of the bias is the proportion due to the non-zero propensity cases. So if there's some relationship between the response propensities and underlying values on the survey variables, this is this covariation term, the correlation between the response propensity and the answers that they would give, then that creates this second component of the bias. And that's also related to the average propensity, which is basically the response rate in the survey. And so this is the proportion of zeros, and this is the response rate. And so mathematically, there should be a relationship between the response rate and the level of bias. Well, what does the data show? There's this joke about in theory, there's no difference between theory and practice, but in practice there is. And in practice, there doesn't seem to be any relationship between response rates and non-response bias. And there are 6 papers that are widely cited as illustrating this non-relationship. There's the paper by Curtin, Presser, and Singer, which simulated different response rates in a monthly survey that Michigan does, the Survey of Consumer Attitudes. And they said, suppose the survey stopped after 6 callbacks. What would the estimates have looked like? So the response rate would have been much lower, but the estimates don't change. They said, suppose we had done 0 refusal conversion in the Survey of Consumer Attitudes, how would the estimates have changed? It turns out they wouldn't have changed at all. Okay, and these 2 papers are related, and I'm going to talk in detail about Groves and Pacheva. What Bob Groves did is he found 42 studies where there was some measure of the true score for both the respondents and the non-respondents. It might have been frame data, it might have been data from a interview, it might have been data from a follow-up, a non-response survey. And they looked at the bias in some estimates from a given survey as a function of the response rate. And the Groves and Pacheva study looked at it a little bit more formally and added 17 new studies. So there's 59 studies in Groves and Pacheva, and I'll come back and talk about that. These 2 studies, I heard that there is an Aldus replication in Germany of these studies. Both studies did telephone surveys, and in one case they tried to use a highly rigorous methodology. They had a longer field period, better interviewers, they had more callbacks, and they had a much higher response rate in one version of the survey than in the other version of the survey. So they had an enhanced survey with many more callbacks and better interviewers and so on. And then they had the usual crummy survey, the standard methodology, what they ordinarily do. And in the first study, there was, I think, on the order of a 30% difference in the response rate. And there were 93 variables in the survey, and there were significant differences on 3 or 4 of the variables. And, you know, with an 05 level, you'd expect 3 or 4 significant differences on 93 variables. So there wasn't much going on. Despite a really dramatic difference in the response rate. I think it was high 20s versus low 60s. This second study, Keeter et al., 2006, replicated the first study. And I think I have a slide. Yeah, there it is, on Merkel and Edelman. These are 2 American researchers. Murray Edelman used to run the group that did exit polls after American elections. And these are all elections. This is a presidential election year. There have been congressional elections here, another presidential election year in the United States on a 2-year cycle. And this is the relationship between the errors in the exit poll and the response rate. So at each precinct, right, which is a place where people vote, Taylor, what are you doing here? Whoa, you run into the oddest people in Germany. So yeah, at each precinct, you have the difference between the Republican candidate and the Democratic candidate, and you can look at that difference as a function of the response rates. And what you'd expect is a negative relationship. The estimate would be closer the higher the response rate. And so the signs are right, but, you know, these are not exactly large correlations, right? They're essentially 0. And in fact, I once showed at a conference what the data looked like here. And I joked that Murray Edelman had been put on Earth so that statisticians would have an illustration of a 0 correlation. I mean, it is really 0 in that study. Okay, and here's the data from Groves and Pacheva, and this is a little bit busy. There are 959 points in this graph. And in these, down here is the non-response rate. And each column represents a study. Okay, so there are a total of 59 studies here, and each study has multiple estimates from it. And the measure of bias that they used is the absolute rel bias. Now, for those of you who aren't, inside baseball fans, what the absolute rel bias is you take the survey estimate, you subtract the true score, you take the absolute value of that, so it's unsigned, and then you divide by the true estimate. And a weakness of the absolute rel bias as a measure is, for example, if the estimate is a small proportion. So, for example, say the survey estimate is 2%, and the truth is 1%, and then you divide by 1%. That's a 100% rel bias. So many of us would think, gee, 2 versus 1, that's kind of close. But you see points here that are 100% rel bias. And that doesn't mean that the survey estimate was all that bad. So one of the sources of skepticism I had about the Groves and Pacheva result was that they used this measure, the absolute rel bias, that I think is susceptible of misleading conclusions. And so you can see there are a couple of extreme outliers, and then here's another one. And what you'd expect overall, if it's the non-response rate, is some kind of positive relationship between the biases, the average bias for a study, and the response rate. And so this is, the most comprehensive look. So I said there are, 6 widely cited studies. 4 of them are one-off studies that involve one survey. And then there's these 2 studies by Groves and then later Groves and Pacheva. That's a meta-analysis looking at 59 studies. So in some sense, I think, God, this is really the smoking gun in this literature. It tells us what's going on. But there are 2 conclusions that people have taken away from this study. First of all, there's the conclusion that I started with that violates it's survey heresy, that there's no relationship between the non-response rate and the non-response bias. But the other conclusion is that what do you take away from this is that there's tremendous within study variability, right? I mean, in principle, right, if you go back to my equations, bias varies variable to variable, right? And what this says is, gee, you can't really draw any conclusion about a study. You really have to look at it variable by variable. So that's the second conclusion here. The second conclusion, this one, is very important because it says no one number can really characterize a study, right? So the R indicator isn't going to work any better than the response rate because there's no one number that says this study produces good estimates or this study produces bad estimates, right? It really depends on the estimate. Or at least that's the conclusion people have taken away from Groves and Pacheva. So as I noted, I've always viewed this study with a little bit of skepticism because I thought that the absolute rel bias is even though it makes a lot of intuitive sense that you'd look at that, it can be very misleading. And when you see estimates like this, the 2 I've circled in red, you see what the problem can be, and you wonder, well, how bad are those estimates really? Okay, so I decided what I would do is I just look. Most of the estimates that they examine in their studies are proportions. And with proportions, you think, okay, you have 2 numbers, 2 proportions, and why not just look at the difference in the proportions? And does that affect the conclusion? And it turns out of the 596 estimates they look at, about 2/3 of them are proportions. So I'm not throwing away a huge amount of data. And what you see is that the correlation between the response rate and the absolute difference in proportions between what you should have gotten and what you got from the respondents is 0.34. If you look at the absolute rel bias, it doesn't tell a tremendously different story. If you just look at study level means, another thing I thought was, if you look back at the chart in Groves and Pacheva, it's designed to emphasize within study variability. They never even show you on the chart what the mean or median is for each study. And it could be that, once you get rid of the within study noise, you'd see a pattern. And that was not true when I looked at the differences in proportions. These are the study level means, the correlation between the study level mean difference and the study level response rate. Whereas if you do look at the absolute rel bias, actually the correlation is, again, it's not striking, it's not 0.9, but it is pretty high. And the third thing I did was, okay, so I'm worried about this thing. Okay, maybe the non-response rate isn't a predictor, but is there any study-level characteristic that might predict non-response bias? And so I did a one-way analysis of variance, where the independent variable was the study, and the dependent variable was the estimate of non-response bias. And you account for 58% of the variance at the study level. Okay, so it may not be linear, but there is a tremendous variation across studies in the average level of non-response bias. And here are some statistics. So the X's are the mean relative bias by study, and these are the median rel biases, and you see a relationship, and it's downward to the right, what you'd expect. The R squared, this corresponds to that correlation of 0.339. This is 0.339 squared, I think. And this is the other correlation I had up there. This is the medians rather than the mean by study. And again, I was worried about these outliers, so I used the mean. But you can see that the conclusions are similar. There is a relationship between the non-response rate and the non-response bias, which is reassuring to old fogies like me. But it isn't very striking, and there's clearly a lot of other things going on. These are my superior statistic, which is just the absolute difference between the correct proportion and the obtained proportion. Doesn't do any better. In fact, it's worse. Don't tell Bob Groves I said that. He was right about to use the rel bias after all. Okay, so what do I take away from this reanalysis? They were nice enough to provide me the data, by the way, and were sweet about it. They know what I'm up to. And so there is some relationship between non-response rates and non-response bias. There are clearly other characteristics of a study that aren't related to the response rates that are, in fact, related to the level of bias. And in the original paper, I don't know how many people have read the paper, but in the original paper, they see a systematic difference according to how they estimated the bias. So in some studies, as I said, they had screening data, and they're comparing the screening respondents to the main study respondents on the screening variables. In other studies, they just have frame data. So many of these are health studies, and so they have sort of detailed information about the person's health from whatever records they use to select the sample. And then in other cases, they do a non-response follow-up. And I've forgotten what the finding is, but those three methods produce systematically different average levels of bias. So that's one study level characteristic that could affect it. And I'm still interested. I presented these data in Leuven about 2 months ago, I guess, and I still haven't gotten back to looking at, can I discover other study level characteristics that are predictors of non-response bias? But the idea that it's only an estimate by estimate thing seems to me a mistaken impression. That there are study level characteristics, which I undiscovered as yet, besides the response rate, that also contribute systematically to non-response bias. And how much time do I have left? 10 minutes. Okay, so I think I'll go through this slide and then jump to some other things. When I first got into this worry about why doesn't the non-response rate predict the level of non-response bias, I thought it'd be worth it to think about what are some mechanisms that might produce this result. Right, and I was joking before that it could be that God loves survey researchers, and he's arranged for non-response to be a completely random phenomenon that introduces no additional bias. I mean, that's number one. But some of the hypotheses that I've come up with, and I don't know that they're all compelling in particular, but one theory I've heard, and that I actually think might be true, is that non-response is the product of a lot of relatively transient factors. So I think about when it is that I pick up the telephone to talk to somebody and whether or not I continue speaking with them after I pick up. And in our particular residence, some of the phones have caller ID and some of them don't. And if I'm upstairs, I might pick up the phone because we don't have caller ID up there, and I think, oh, it's my children, I better pick up. And then it turns out to be, hi, we're calling from the Gallup organization, you know, but it's purely a random thing. And it could be that there are a lot of little random factors, like whether you're feeling good that day, whether you're in your good mood, whether you're in the bedroom without caller ID or downstairs with caller ID, you know, 50 little variables, and you do 50 coin flips, and so, and that's how you determine your response propensity at that moment. You've just done 50 little coin flips, and it can't possibly correlate with anything because it's this sum of random variables, none of which is very important. So that's one theory. That's this second theory. Or it could be that such systematic factors that matter are study-level characteristics that are unrelated to the respondent characteristics, right? So if you do a face-to-face interview, chances are you're going to get a higher response rate than if you do, you know, a telephone interview. And it's a dramatic factor, right? You know, it might produce a 50% difference in the response rates easily. And, you know, and that has nothing to do with anything the respondent is going to tell you, right? From the respondent's point of view, it's just orthogonal to their characteristics, and so it can't matter. That's the second theory. This is this theory. No, actually, this is the first theory. It could be that, you know, there are a set of respondent variables that matter and that determine response propensities, but they just don't happen to be ones that are highly related to the survey variables. So my list of favorite variables that predict non-response are, in the US at least, if you're a male, you're less likely to respond. If you're older, you're more likely to respond. If you're a young male, you're particularly unlikely to respond. They're worthless. I see all the women here shaking their heads. The men here are equally worthless, apparently, in the 20s. If you live in a big city, you're less likely to respond. If you're highly educated, you're more likely to respond. You know, there are 5 or 6 factors that account for, you know, 50 or 60% of the variance in response propensities, and they just don't happen to be very interesting variables. Other than being related to response propensities, they're not much related to anything else. And the variables that produce large biases are the ones that are related to these otherwise dull variables. Another theory, so that's this idea, and also this idea. Another idea is that most of the bias comes from those cases that have essentially zero propensities. So there are people, as I said, in a web survey that will never do a web survey. Or I believe in the United States now, there's something like 60% of the population or something would never participate in a telephone survey. It's just, you know, the ceiling that you can't get past is maybe 40%. You know, the world's telephone survey in the U.S. is unlikely to break that ceiling. I don't know what the number is really, but you get the point. That there's some big zero propensity stratum that isn't observed in any studies, and they're the ones who produce all the bias. So those are some thoughts. Another thought thank you. Another thought that I've played with is that the relationship, there could be a relationship, but it's not linear. And it is related to the response rate. So at the two extremes, like for example, there are still studies in the United States, like a population study, that have a response rate of 90%. And then there are other studies that characteristically have response rates of 5, 6, 7%. And the point is, the response propensities can't vary very much across people if the overall response propensity is 0.9. Likewise, it can't vary very much over people if the overall response propensity is 0.5. And so at those two extremes, you just don't see much bias. But in the middle, there's room for there to be a relationship between the response propensities and the bias. Okay, so I have 5 more minutes, so I'll go a little faster. Paradox number 2 is derived from the idea that no one number can characterize a survey. And the two alternatives that people have proposed, both of which have attractive features, won't work any better than the response rate because, as I said, there's this tremendous within-study variability. And you really can't characterize the overall bias in the survey by any single number. And the R indicator, for those who, again, who aren't survey guys and haven't kept up on this literature, it's basically 1 minus twice the standard deviation of the propensities. So you can just think of it as the variation in the propensities, right? And if and you know that if everybody has the same propensity, you have no problem because that's God loves us, and He's made a non-response a completely random phenomenon. That's that hypothesis. And in statistic ease means that all the response propensities are identical. You don't have to worry about bias. As I said, the Dutch have pushed this, and so it could be a good indicator of bias, or the threat of bias. And then the Swedes have advocated this balance indicators. I won't go into the math of it, but imagine you have a vector of sample characteristics like the percent female, the percent male, the percent high education, the percent middle education, and then you have the population figures, and you take those squared deviations and standardize them, basically. That's what this expression says, balance in this vector here. And again, if the within-study variation in bias swamps the between-study variation, then you're sunk, and no one number is going to tell much. And so that's a key problem. I think that that's not right. I think my reanalysis of Gross and Pateva at least persuades me. It may not persuade anybody else in the world, but it persuades me that there is a huge between-study component that's worth trying to capture. A problem with the R indicator is that people who fit these propensity models, and I'm guilty of this, you often have an R squared of 0.02, which means that all the propensities are right at the mean. And so it looks like there's not much variation in the propensities, but it just means that you don't have any good variables for predicting the response propensities. And so empirically, the propensities don't seem to vary very much. I like the balance indicator because I think it's a neat proxy, but it has a similar problem, which is that in Sweden, where they know everything about every Swede, this works beautifully because they have really good auxiliary data. But in most countries, like in the United States, you dial a phone number and you know precisely nothing except the phone number, about that person. And you can do some things, but I mean, you don't have the kind of good auxiliary data that would allow you to create a good balance indicator. And there's been a flurry of activity. I came from a conference in Manchester on these adaptive and responsive designs. And responsive designs means that you do things in phases. Phase 1, you do something. Phase 2, you change the protocol to try and reduce bias or reduce cost or whatever. And then you might even have a third phase. In adaptive design, you try and tailor the data collection strategy to different subgroups from the outset. And here's an example that the Dutch did. Annemieke Louten and Barry Schouten. They, in phase 1, they had done a similar study in the past. They were able to predict that certain kinds of people would have a high chance of responding, others would have a low chance of responding. The cases with low propensities were sent a mail questionnaire. Those with the highest propensities were sent instructions to complete a web survey. They were hoping to save money. So these easy guys will respond anyway. Most people prefer a mail survey, even in the Netherlands. And so these guys got a mail survey. And then those in between were given a choice. And the goal here was to try and equalize the response propensities across these groups. And then in phase 2, where they did non-response follow-up by telephone, the people in the highest contact propensity were fielded later and were called during the day, right? So when most people aren't home. So, and then those in the lowest 2 contact quartiles were called all the time. So they got more calls. So in both phases, they're trying to compensate for pre-existing differences in the propensities. In phase 1, they're focusing on cooperation. In phase 2, on contact. And this is a kind of busy table for a guy who has exactly a minute left in his talk. But they were able to bring the contact rates, they vary in the experimental group from 87 to 95. Here it's 84. So there is some convergence in the contact rates. And likewise, there's some convergence across groups relative to the control in the cooperation rate. So they had partial success. You know, I mean, in the ideal, in the experimental case, the 4 numbers would be identical, right, in both panels, right? I mean, if the propensities were perfectly equal. Okay, I'm going to skip, okay, to here. And so people at Westat, Brad and Mike Brick and others have been trying to think about, well, what should Westat do in the face of these problems and these new techniques, responsive design and adaptive design. And a lot of studies do things differently at the end. Some have a formal phase 2, maybe they subsample the remaining cases and go after the subsample. And some have a less formal phase 2, but they do things towards the end of the field period that are different from the protocol that they used earlier. Maybe they increase the incentive without doing subsampling and so on. And so the thing that Mike and I have been trying to figure out is, well, what should you do? What's the goal of phase 2? What's the best thing you can do? And we've been impressed by the work that Karl-Erik Sarndal and Peter Lundqvist have done in Sweden. And in phase 2, they did a move that you rarely see in a survey. They simply stopped interviewing some cases. They gave up on the high propensity cases. Why? Because they don't want the high propensity cases to get any higher. And so if the propensity in phase 1 is higher than some constant, and they ended up with roughly a 65% response rate. So they basically said, we're not going to do anything else on groups that have a 65% response rate. We're going to give up on them. We're going to cap their propensity at 0.65. Okay, so that's this. And then for the other cases, what you want to do is you want to have a phase 2 propensity that brings them to this K, to 0.65 in the Swedish case. Now, you can't always do that. But so you'd work the low propensity cases harder than the high propensity cases, or you'd change the protocol somehow for these low propensity cases. And in the US, changing the protocol somehow usually translates into one of 3 moves. You offer them a lot more money. Okay, you boost the incentive. You shorten the questionnaire, sometimes dramatically. You know that 20-minute interview you refused to do? It's 5 minutes now. Do I hear 4? Right, and then the third thing you can do is you can change modes, right? And so a lot of surveys, American surveys, they start out cheap, and then you'd send in telephone interviewers or face-to-face interviewers to boost the propensities. And if you could equalize the phase 2 response propensities, it can be shown algebraically, even by me, so it's not a very difficult proof, that you cut the bias by a factor. If 50% of the cases come in phase 2, then you cut the bias in half. Or at least you cut, this covariance term, the impact of it in half. So that's worth doing. I think, okay, we've already covered this. There are real limits here. And one of the things that I think is neat about the work in Sweden is it turns out we understand way better how to lower response propensities than how to raise them. You know, and we're much more effective at lowering the response propensities. You know, hiding the cases from the interviewers, it turns out, is tremendously effective at lowering the response rate. And as I said, we had a limited number of moves that are commonly used in the United States, and there are problems with all 3. So, for example, on incentives, Westat recently completed a review of the literature on incentives, and it turns out that the diminishing return curves on incentives is very steep. So the return on an incentive flattens out in the U.S. about $20. And then going to $50 gets you maybe an extra 1 or 2%. And so that's the limitation. As I said, you can change the mode, But if you start out, like many surveys do, in face-to-face, you're out of moves. You've already used the best mode you could possibly use, and what do you do next? There isn't anything better than face-to-face, it turns out. Or you could shorten the questionnaire, but of course then the analysis gets really complicated. And unless you can impute the rest of the data or something, the analysts will be bitter and disappointed and hate you and curse your children. And another thing that comes through in this literature is a lot of times people are just floundering. And it isn't exactly responsive design when you sort of did a pretest and you knew what the right thing to do, but then you don't do that. There's evidence that once people have said no to one approach, they're more likely to say no to another approach, one that they would have said yes to had you used that in the first place. And so there are advantages to doing it right from the beginning. And then I've already mentioned this point, that it's often easier to know how to lower response propensities than how to raise them. Okay, I'm just going to quit here. So thank you very much.
It's not really a question. I have two related comments on the first paradox you mentioned. Let me start with thanks for this really inspiring talk.
Depressing talk is what you meant.
Yeah, sometimes you might even find this inspiring. The first paradox you mentioned was this missing relation between response rate and bias. I'm wondering whether one reason which contributes to this missing relationship, or maybe you detected some kind of relationship, but I'm always wondering, at least given my experience with German surveys and also surveys in Europe, whether the high response rates which are sometimes reported are really reliable. My guess is that, at least in part, some surveys which have seemingly high response rate, when you look at the fieldwork effort which was put into them, and if this is also quite low, I had some really serious doubts whether this is a valid report on the response rate. There is some undocumented substitution taking place. That would be my guess. And so response rates, especially the higher ones, might at least in some cases be inflated. And that might also contribute to that the relationship we would usually expect is lower than we would expect. And related to this point is that you asked for other survey design features which might help to explain the level of non-response bias. What we find in Germany and also in European studies is that when you look at the type of sample which is used, that this has an effect. And more specifically, it's the involvement of the interviewer in the survey design. The more tasks interviewers have to do by selecting people within households or by doing some kind of rendezvous to find out about the households, the worse the results usually are. And this is when we try to explain some kind of indication of non-response bias, usually more influential than the level of the response rate.
Those are both interesting comments. Thank you. I definitely plan to look harder at, on your second point, at the study characteristics. There's a lot of variation in the population of the 59 studies. And as I said, a number of them are health studies. And you could imagine, for example, just as a main effect on the response rate, if you're surveying patients and you're at the hospital or something, you might expect, because of that relationship, you might get a very high response rate, but still nonetheless get a high non-response bias, for example. And so it definitely bears a lot of scrutiny. I take a backseat to no one in my dislike of how badly interviewers do surveys. I'm with you there. No, I think you're right that there can be problems. On the first point, Bob Groves was one of the people who created the APOR standards for response rate reporting, and my guess is they did a fairly good job of vetting that the response rate was pretty well calculated. But I should look at that point again. I mean, I think in general you're right that a lot of survey firms, how shall I put it, they have social desirability bias in their reporting of response rates. Is that a tactful way of saying it? And I think it could be a problem. But I think in Gross and Pacheva, they would have been sensitive to that kind of thing. I think they recalculated most of the response rates themselves. But if the underlying data are incorrect, if for example, there was substitution or something, you wouldn't necessarily be able to see that. So those are really good points. Thank you. Hi.
It's very useful to hear it again. And also because the first time I heard you talk, that was before the TSE conference.
That's right.
And then after. And at the TSE conference, there was a lot of talk about probability and non-probability samples, especially web survey and so on. And if you hear your talk and you have that in the back of your mind, of course, the first thing you might think, well, why bother about response rates at all? Why not just go on probability? I don't know what you think about that.
Yeah, I think it's a really good question. And I don't know if you were there when Andrew Gelman was talking, but Andrew Gelman is were you there for his talk? Yeah, well, for the rest of the group. Andrew Gelman came on. He was on the TV screen. He was huge. I don't know why he was on the TV screen instead of being there, but there he was, 50 feet of Andrew Gelman. The Bayesian monster unleashed on the rest of us. And I thought he made a very good argument in favor of abandoning probability sampling. And his argument was something along these lines. If you get an 8 or 9% response rate, you do precisely the same kinds of modeling and weighting adjustment that you do if you started a non-probability sample. And it's not clear that you end up with a product that's any better than you'd end up with. And the only response I have to that is in the book on web surveys that me and Mick and Fred did recently, which you should all have 2 or 3 copies of on your shelf. A little Michael said I could do a little infomercial. But anyway, there are about 6 or 7 studies, the best of which is Krosnick and Chang, or Chang and Krosnick, I think it is, where they look at the results from non-probability and similar probability samples. And in every case, the probability samples look better, at least in terms of representativeness. Now, if I were Andrew Gelman, I might argue these variables that are used to assess representativeness are things like sex, age, education, that you can easily fix in the weighting, right? And why bother to collect expensive data when you can clean it up at the end? But I'm persuaded by these studies that even when you don't have, even when you look at other variables that are not these standard demographic variables used in weighting schemes, you see improvements in probability samples relative to non-probability samples. For instance, if you include an item, say, from the health interview survey in the United States, which again is one of these surveys that still gets like a 90% response rate, and you use that as the benchmark, how close do you come to the HIS benchmark in a non-probability sample versus a probability sample? And there's not 100 of these studies. There's a handful of them, but they consistently show that the probability samples yield better results. So I'm persuaded that if you can afford it, it's worth it to start with a probability sample, even if you have to do a whole bunch of statistical cleanup at the end. That's very similar to what you'd have done, had it started out in life as a non-probability sample. Go ahead.
Can I just add my opinion?
Sure. I'd love to hear your opinion.
I think the main issue about this probability and non-probability samples, and the reason why we see these differences, is not non-response, but non-coverage. And I think this is an area where we goes a bit in the direction of what Achim also mentioned, because if interviewers don't go to certain households or whatever, that's really non-coverage, it's not non-response. So maybe that's with non-response bias research is also.
Yeah, I'm with you. I mean, I do think there's a large group of cases that are essentially zero. That's what I meant by zero propensity. It's these cases who are essentially not covered. And I think that they could be very different. And I also agree that percentage is much, much higher in the typical opt-in web panel. I mean, you know, I'd say like 90% of the population is in the I would never join an opt-in web panel. Roger Tourangeau, you heard it here first, has zero propensity for joining a non-probability. Mick Cooper, on the other hand, I can tell you, is 3 or 4 of them. A total survey junkie, that guy. Yeah. Well, thank you all again.
Thank you.